and
Okay.
then you can continue because the participants must know what is going on.
Yeah, okay, okay, yeah. And so nice of you. I mean, it will be share some of those areas also.
So, good evening, participants. Today we are with our fifth session, and in this faculty development program on innovation and challenges of energy storage technologies, we have discussed about the controllers, about the phase lock loop, and then SIC based converters, controllers, and then the battery management system. So today we'll be having discussion on batteries employed for EV in India and suitable domestic charger design for the Indian context by our expert Dr. Dipankar Debnath from IIT Kharagpur. And I would request on behalf of MANIT, Malana Azad National Institute of Technology, and our organizing committee, uh, I welcome him for this faculty development program. He has kindly consented for having a talk in this session, and despite his busy schedule, because he was traveling in between, he is still in Delhi, and we hope that we are not bothering him too much. So thank you very much, Dr. Devnath, and I would request Dr. Shailendra to please introduce our eminent professor to the audience.
Sure, sir. Is it audible?
Yes,
Yes.
yes.
So, Dr. Dipankar Debnath joined IIT Kharagpur as an assistant professor in electrical engineering department in 2016. Recently, he was conferred with Faculty Excellence Award, IIT Kharagpur 2022. Prior to joining IIT Kharagpur, he has worked as assistant professor at IIT Indore and as a research associate at IIT Bombay, both at electrical engineering department. He was conferred with a PhD degree from IIT Bombay in 2015 for studies in electronics and power systems. He has done his ME from IIT Tirupur, West Bengal, and BE from NIT Agartala, Tripura. His research interests include design of integrated power electronics converter topology, design of solar photovoltaic based standalone off-grid systems for rural areas, multifunctional inverter for grid integration of renewable energy sources, study of microgrid, motor and motor controller design. With this, I would like to invite Uncle Devnath sir. Uh,
Thank you, Dr. Shailendra, for the nice introduction. And let me start. And thank you to the entire organizing team. I know how difficult to organize such event. It takes a lot of time and effort. And also special thank for giving me opportunity to talk to a different set of audience, which is always enjoyable. Especially the question I get during this kind of session is helpful in our next level research work. Also, please consider this as a personal invitation. If you happen to visit Kharagpur or nearby area, do visit us. We have decent facilities for various testing and experimentation. Recently, we are mostly focusing on the electric vehicle area. Also, we have support for renewable energy and other work areas. So if you happen to visit us, do visit our labs, and we'll be happy to have you, and we want to show you some of the facilities. And if you are interested, you can also contribute to our projects, which I'll discuss at the latest stage. And also, if we are always open to have some sort of collaborative project. Maybe if you have some skill which are complementary to us, we can jointly write a research proposal, etc. So with this background, let me share my screen. And first, as I discussed, uh, let me talk about this my trip to IIT Delhi and why I came. Basically, to showcase one of our recent project outcome, which I think will be relevant also for this short-term course. And then we'll shift towards more on the battery charger, etc. In between, if you have any question, please feel free to stop me. because it is a very long session. I'm sure if you allow me to speak continuously, definitely you will feel bored. So please stop me in between if you have any question. Also, in between the session, I'll be asking you a few easy questions, more or less revision question, and I request you to respond to them to session as interactive as possible so that it is an enjoyable journey for you as well as for me. So in this first 10-15 minutes, let me quickly tell you about this project, which we did for this electric three-wheeler. Before I start, please confirm whether you can see this word welcome on the left side.
Yes, sir.
Okay, just to check whether my writing pen is working or not. Thank you. So this kind of electric three-wheeler are very popular in India, especially in the semi-urban areas and also in smaller cities. Now, these electric rickshaws, they generally use BLDC motor of around 850 to 1 kilowatt, 850 watt to 1 kilowatt, and also a motor controller of compatible, I call it MCU, motor control unit. Okay. Now, unfortunately, all these components are now imported from a neighboring country. So, there are a lot of problems associated with it. We are lacking on the job, we are lacking on the expertise and all these things. So, our main target was to develop these components indigenously, starting from scratch. So that we have all the know-how of this entire technology, and we should have also detailed data which we should gather from on-road testing, etc. I'll tell more about it. So what we came up with is basically this unit in a product form. This we are calling as a MCU plus VCU unit. It is not like a regular motor controller. It has some added features. I'll tell you more about it in the next slides. And we also designed and fabricated in-house a BLDC motor, which is slightly in higher rating as compared to market available solutions to give you edge on the gradient or loading capability. Also, this motor is ICAT certified, which is also quite unique in this category of vehicles. It is ICAT certified for IP67 as well as AIS Automotive Industry Standard 041. And some of the feature that we developed in the controller that needs communicating with the driver through a display. So we also developed a display. Rather, we took a display from the market and we have programmed it so that we can show whatever additional information we want to show to the driver. So this is the entire package. We have the in-house BLDC motor. We have a BLDC motor along with vehicle supervisory control. Also, we have a display to communicate most of the important features to the driver. This project was funded by Ministry of Electronics and Information Technology, Government of India, and we had a very strong industry partner, Brushless India Private Limited, in this collaborative work. And recently, I came to IIT Delhi. There is an Penn IIT R&D fair. So they are showcasing various innovative IIT projects to the greater audience, to the industries, to the different official staffs. And around 75 projects were shortlisted from 23 IITs. Fortunately, one of them was ours. So we came here to showcase this. Now, let me tell you the main problem statement that we are working on. Some of them I already told you. Present day e-rickshaw, they have a motor control unit. They take input from the accelerator or throttle, whatever you call it. And that, based on that, the energy stored in battery, they give it to BLDC motor, and that converts that electrical energy to mechanical energy. And finally, that is given to the wheels. Now, main problem, as I told, mostly they are coming from foreign countries. So indigenous development, our manpowers are not getting trained in this particular area, job market is less, and several other issues. And since these are imported, they are not dedicatedly done for India, of course. Sorry. They lack Indian certifications, and they lack regenerative braking. Some of them is a open loop controller. So it's not well done. But basically, they target very low cost solution, and that's why they miss a few features which are required in this category of vehicles. So these features actually are done through a vehicle control unit or vehicle supervisory control unit, which is generally there in high-end vehicles. Now in high-end vehicles, costs are high. So you have a separate motor controller unit, you have a separate vehicle control unit. But in e-rickshaw is a very cost-sensitive segment. You cannot have luxury to have these different units. So what we proposed is that in the motor controller itself, we already have the microcontroller. Can we make it more powerful so that we can also integrate some of this required vehicle controller functionalities? So this is what we done, and some feature we have added. I will show you one by one. So this is for this particular category. This is the first product which talks about these additional features. Then we also talked about the custom display unit and also a BLDC motor, of course. These are the specifications. E-rickshaw generally operated with 48 volt, 100 ampere hour lead acid battery. So you have to design your motor controller to be suitable for this voltage. And one of the main requirement of automotive kind of application is that whatever is your rated torque requirement, starting torque requirement is much higher. So if you take this as an example, typically the e-rickshaw available in Indian market, they have torque of around 3 to 3.5 Newton meter. Okay, and speed of around 2800 rpm typically, which is suitable for 25 kilometer per hour kind of speed, which is the maximum speed allowed for this category of vehicles. But the starting torque requirement or torque at low speed becomes pretty high. Our analysis has showed that we need at least 20 to 23 Newton meter kind of starting torque. So you need a special design for that. So we did all these things. Let me not go into much detail. And what we proposed is basically a motor controller unit which had two different board, one logic board and one power board. In the logic board, we have all these intelligent features. For example, we have this control over regenerative braking and a blend between regenerative and mechanical braking. Then we have range prediction, how many kilometers you will be able to drive, which is again an industry first feature for this category of vehicles. Then there is a interesting feature called false status monitoring. Now assume that your vehicle has stopped and it is not rotating. So there must have been some fault somewhere, right? Now, how do you know where that fault has occurred? If I could give to the driver or the technician an error code, which will say that look at this particular location, you will get your fault, right? So that kind of study we had done, and we have located around 26 faults. So for example, sensor fault in BLDC, over temperature fault, under voltage, over voltage fault in the battery, etc. So we track those faults and we generate an error code and we have a list of faults. So technician would easily see error code 5. He knows or where exactly that fault has happened, and it can be repaired easily. I'll show you a demonstration also. And we also have a power board where basically this MOSFET and driver circuit, etc. the main power component of your motor controller. Now idea is that main intelligent portions are there in the logic board. So if you want to change the power rating of this controller, let's say you want to do it for two-wheeler or heavy duty electric three-wheeler, you change the power board, your logic board remains the same. Okay. And that's how we did all these VCU and MCU functionalities. This is how we implemented. Let me not talk about it much. These are the several features that we have additionally as compared to the market available solution. Most of them I already told you. Also, we have further scope for customization in the sense that if a vehicle manufacturer comes to us that you have this many features, can you please add one or two feature for us? You will be able to do that because every now code, every design we have from the scratch. And motor benefit we are having is that it is ICAT certified, as I told earlier. Also, the temperature performance is in our motor, so its lifetime is higher. The rated power torque is higher. Okay, it is more efficient. The combined efficiency itself is more efficient, especially at half or one third of the rated speed, where e-rickshaw runs most of the time in city driving conditions. There, our total solution is at least 5 to 6% more efficient than standard solution or off-the-shelf solution. So these are some of the features, and these are some blown out image of the BLDC motor that we developed. This is the motor controller in finished form, and this is a blown out version so that you can see this logic board and power board are different, and it is not like the standard solution. Of course, if you want, you can combine them into a single PCB also if you want to reduce the cost. So these are some of the results we already tested on e-rickshaw, and you can see this display. We also logged data in the mobile, and you can see an example of regenerative braking here. So as soon as you press the brake, this color is for braking. You see there is some regeneration happening on road. So this is how we generated some data and we analyzed. This is the display unit during healthy conditions. So it will tell you what is the remaining range, what is the best battery SOC, what is the speed of the vehicle, how much kilometer was traveled. And this drive mode will tell you whether it is forward or reverse. And if any fault comes, then it will show you that error code. Okay, so you have to restart the vehicle and it will solve this. So quickly, I'll tell you, I'll show you just a 1 minute video how these things were mounted and tested. The video does not have any sound. Just look at those components where they were mounted. The package will look slightly old because this video 5-6 months back. So here you can see the regenerative braking. Basically, you had a brake sensor mounted. Then we have loaded the rickshaw fully. We did testing on gradient condition, forward, reverse. Also, this is the display during driving. So basically, you might have seen that one error code was generated, which was for under voltage. And once we cleared that fault, it was healthy again, and finally we could restart the system. So these are some of the features that I have again a long video of 11 minutes, which is there in my YouTube channel. If possible, please check that if you're interested, of course. So this is all about this particular project. We are also working on some other motor, for example, synchronous reluctance motor, PMSM motor, motor controller as part of different other projects. Yeah, can you please confirm whether you can see this second topic, batteries employed for EVs in India?
Yes,
Yes,
yes.
sir.
Yes,
Okay.
sir.
If you have any question for me regarding this previous short presentation, you are feel free to ask in case if you wish, or else maybe you can interact at the end also.
Sir,
Yes.
what is like, I mean, like,
Shailendra, your voice is breaking.
hello,
Yeah, voice is breaking. Yeah, now it's okay.
sir. I wanted to know what is ICAT certificate? I mean, it is related to motor efficiency or some other parameter.
Okay, that's a very good. See, whatever product you develop for automotive industries, right, like three-wheeler, four-wheeler, if you want to go for certification, you can go to ARAI or ICAT. Now, there are different standards for different category of products. Now, IP67, what does it mean? Is that this product is, even if you operate in dusty environment, it is safe. So now, I don't know whether you have, if possible, you look at how the motor is mounted on e-rickshaw. It is mounted between the two wheels on the rear side, and it is open to the environment. So a lot of dust, etc., will come into the in touch with your motors. It must
Yeah,
be
it is.
protected from dusty environment. And then number 7 indicates that even if the motor is inside water, 30-meter depth for 30 minutes, not 30 meter, I think 1.5 meters, sorry, not 30 meter, 1.5 meter depth for 30 minutes. And then you take out the motor, it should be able to run. So now, there are several cities during monsoon season, they get water logging kind of scenario. So our motor will be able to sustain that if the duration is, it is tested for 30 minutes. ICAT has tested and it is certified. So this is IP67 ingress protection, and AIS 041 is basically, it certifies that whatever specification you are mentioning. For example, I said my motor is continuously rated for 1.2 kilowatt. So ICAT has tested it in their lab and certified that. I said my peak power is this much. I think 1.7 kilowatt we mentioned for some duration. So they've tested it and they verified officially that is now proven for this particular rating. So your power rating, etc., verified. And then there are some other standard for EMI, EMC, and some other environmental, etc. I hope I could clarify. If you have any question, please you can ask.
Please continue, sir.
Okay. Thank you.
Sir, one disadvantage is there, na sir? It is very low speed, na sir? How to increase the speeds?
Yeah, for this category of vehicles, speed is limited to 25 kilometer per hour. It is Government of India guidelines. So even any vehicle which is beyond 25 kilometer per hour, you have to apply for a lot of registration and other formalities. Below or on or below 25, you don't need to go for a lot of certification and registration. That's why this category of vehicle is very popular. Okay, but it does not, cannot design electric rickshaw, or now you see e-autos like Bajaj Chetak, they can go beyond 25 kilometer also. So basically it is how you are designing your motor and what gear ratio you have selected. So you can achieve that. But for smaller vehicles, right, like e-rickshaw, going at very high speed will attract a lot of accidental issues. That's why it is generally not preferred beyond 25 kilometer per hour.
Thank you.
Another restriction is on the DC voltage side. Generally in India, if you design any system having voltage of 60 or higher, DC voltage I'm talking about, you have to go with a lot of safety related certifications. But if your system is less than 60 volt, you can bypass those certification requirement. That's why you see a lot of vehicles use 48 volt because it does not need many certifications. But as soon as you go for higher voltage, you need a lot of additional safety related certifications.
Okay, sir. Thank you.
Thank you. Yeah, keep asking questions, right? Otherwise, everyone will fall asleep. Thank you. Thank you for being so nice, audience. Now, let me take you to this something related to batteries. Again, the exact work I am doing on the battery, detailed battery charger, that I won't be able to share due to some NDA agreement and IP related issues. But what I would give you is more or less a generalistic ideas and some problem statement also, maybe if time permits. And I would also try to show you some simulation demonstration, how you can simply design a standard charger. Okay. And I will also tell you about which vehicle uses what battery, what voltage level. So that kind of market survey we will have, so that you can get a clear idea like which batteries is being used by two-wheelers, what is used in three-wheeler, etc. So we'll take you to the journey, and then we'll understand the standards, connectors, and then is a very simple design and simulation. And hopefully by that time, uh, I hope you will still have some energy to interact. So this is the agenda. I won't spend too much time on the types of battery, etc. I have a detailed presentation on that. If you wish, just drop me an email, I'll share you. But today I'm not speaking much on the types of battery. Rather, I want to show you what battery is being used, what type of battery, what is their specifications, etc. And so if you look at the batteries that are being used in Indian context, right? I'll show you detailed market survey also in a few minutes of time. The three-wheeler e-rickshaw that I showed you, mostly they use lead acid. Some of the low-end two-wheelers, typically costing less than 50,000 or so, they use lead acid. But slightly high-end scooters or bikes, they use lithium ion. And a lot of people are now also trying to develop sodium ion batteries. If you come to this R&D fair, you would have seen some sodium ion batteries on display also. And apart from that, few other people are also doing on some other different battery technologies to make it more compact, more energy density, more safer for electric vehicles. And if you don't want to go into deep of this battery manufacturing, etc., as a electrical engineering, still you need to understand what is the battery voltage, what is the ampere hour capacity, right? What is the watt hour, what is SOC, state of charge, and then SOH is also a very good topic nowadays. A lot of people are working on it, state of health of the battery. So we'll also slowly understand some of these terminologies. Then as per your specification, you need to connect the batteries in series or parallel, right, to meet the voltage requirement, to meet the rating requirement, etc. And specifically, when you connect several batteries in series, there is a chance that one of them will charge more, one of them will discharge more, right? So that can create a charge disbalance. To equalize this now, and also to offer a lot of safety and other related information, people use battery management system, which are inbuilt in most of these lithium ion batteries. But lead acid battery, you won't get any battery management system in market readily available, especially for two-wheeler or three-wheeler segments. Later on, I'll show you that e-rickshaw batteries are basically 12 volt batteries, 100 ampere hour, connected four of them in series. Okay, so totally it is basically 48 volt pack, 100 ampere hour, and it is lead acid, and they are just connected in series. There is no BMS, nothing involved. So the SOC, how do you provide range estimation? That is one of the challenge we solved in this last project that I showed few minutes back. Whereas the lithium ion cell, typically they will have a single cell of 3.9 volt or something like that. And they keep on connecting those cells in series to get 48 or similar voltage levels. And for each of those cells, they will be having some sort of passive or active way to balance between all these cells, and they can have this SOC estimation inside and some other parameters. Now our product also had, our motor controller unit also had a CAN communication, which can talk to the BMS of the lithium ion battery, and it can extract the required information like SOC, the battery pack voltage, battery temperature, which is required for our range estimation and safety features. So again, this was also industry first feature in this particular category. We are the first who said that our motor controller is capable of lead acid battery based range estimation. Also, we have communication to read data from BMS of lithium ion battery. Presently, all the e-rickshaws are using, or I would say more than 95% are using lead acid batteries. But now a regulation came recently and saying that they also need to shift towards lithium ion battery. So we'll take a short journey, okay, based on our basic understanding and a DC power supply that you generally use in the lab, and how can you charge your battery, okay? So I'll give you the problem statement first, and I think this you're familiar, so this also we'll discuss. Please pay attention and help me to um, phrase this question better, and also I would expect that some of you will answer this. Pretty easy stuff. I'm more or less sure almost all of you have used this kind of DC power supply in your lab of different make, maybe App Lab or GW Instack or some other. Now, specialty of this kind of power supply is that generally they have multi-channels and they have a range of typically 0 to 32 volt. You can control by varying this kind of knob. You can set at what voltage you want to set this power supply, and generally they have a 0 to 3 ampere current rating. Again, this limit also you can set by playing another button, another knob. Okay, so those who have used this kind of power supply, please try to relate, and those who have not used, you may ask me if you have any doubt. So what I said, let us assume that in your lab you have a DC power supply of 0 to 32 volt. You can set at any volt, where 12 volt you want, you just adjust the knob, set it at 12 volt. That you can do. Also, you can put a limit on the current. Okay, So let's say it can give you maximum 3 ampere of current, but you can put a limit, say 2 ampere. I will put the limit. So the power supply won't give you current beyond 2 ampere. That facility is there. So independently, you can set current and voltage limits. Okay. This is the DC power supply you have in your lab. Let us assume. And let us also assume that you have a battery 12 volt and 10 ampere hour. And this is a lead acid battery, right? Simple. Most of you have seen this battery in lab or maybe in UPS of your home. Now, the question is how you are going to connect. So this battery will have a plus minus terminal. This controller will also have a plus minus terminal. How you are going to complete this connection, whether you are going to put anything in between, how much limit you are going to set it so that you can charge this battery, okay, to let's say some more or less full charge level. That is the problem statement. So I repeat, you have a DC power supply in lab, you have a battery in lab. Question is how you are going to connect the battery to the DC power supply, how you are going to set these limits, okay, and finally, without damaging the battery, without risking your life, how can you charge the battery? That is the question. Okay. Is there anyone who did not understood the question? Please feel free to ask. Right. So I assume that more or less you have understood. At least one of you, can you please let me know whether I am still audible?
Yes, sir.
Make sure. Okay. Okay. Thank you. So I think more or less all of you would agree. Then I'll leave it to you to answer this question. That most of these days batteries are generally charged with CCCV kind of charging profile, right? First they started CC, which is basically constant current. By the way, I'm going to share you the slides, so you need not take screenshot or anything or photo, etc. I'll be sharing you the slides in case you need it. Okay. So this entire battery related topic, I'll share you my slides so that if you need anything, you can take it from this. Just concentrate on this problem so that we can discuss. That's just for your clarification. So this is the constant. Initially, we start with constant current, and initially battery voltage will be low, of course, right? And then as you are charging, battery will build up. This may not be much low. Peg voltage is on this axis, sorry. Now, before going to this, let us clarify one small point. Let's say a 12 volt, 10 ampere hour battery. Okay. First question, when it is fully discharged, what do you think its voltage will be? Question 2, when it is fully charged, what do you think what will be its voltage? Question 3, what is the maximum current with which you can charge this voltage, charge this battery? Okay, so first question, when battery is fully discharged or more or less discharged, what do you think? What will be the battery voltage? Will it be 12 volt? Anyone, can you quickly help me on this?
It's around, sir, 10.5.
Around 10.5. Okay. And then when it is fully charged?
13.5.
Yeah, 13.5 or sometimes 14 also. Let's say 14 for round figure. It depends on manufacturer to manufacturer. So you can read the data sheet of that battery and can figure out. So 12 volt is the nominal voltage. And this is the range. Okay. What about this third question? Answer. What is the maximum charging current this with which you can charge this battery? It is 10 ampere hour battery. Anyone quickly?
1 ampere, I think, if we are considering the rate by 10.
Okay. So typically, thank you for your answer. Typically, these lead acid batteries are charged at C by 10 or C by 5 at max. What is C? Basically the charging rate, the rate at which you can charge the battery fully charge in 1 hour. So basically, if you do simple math, it is nothing but this number. Okay, more or less. So C is 10. So 10 by 10 roughly is 1 ampere. Okay. Some batteries you can charge at C by 5. I'm talking about lead acid batteries. Lithium ion batteries, you may be able to charge at completely at C rate or C by 2, sometimes 2C also. Lithium ion battery can be charged or discharged at higher rate. That's why they can be charged or discharged faster. So we understood this is the 1 ampere. So maybe we'll set this current at 1 ampere, right? That can be a starting point. And then we know this limit, right? When it is fully charged, it has to be 14 or something like that. So that is how you can you know. Now I think you have got almost all the answers. So can you help me to solve this? So what I'm saying is, assume this point, I have the DC power supply. And these are your plus terminal, this is the minus terminal, and this is the display where you see how much is voltage, you can see how much is current. Okay. So first point, and this also will have definitely AC input, 230 volt, this kind of DC power supply, 230 volt input, and then there will be switch. So let me call it switch S1. Okay. Basically that plug board switch that you need for turning on this DC power supply, switch S1. And let us put a battery also here, that lead acid battery you're talking about. For some of you, it might be slightly boring, but maybe we'll end up with some discussion. Please hold your patience. So my point is, battery also we know there are plus minus terminals. So maybe some of you would suggest that I can put a switch like this S2, or if you want, you can put some other component here also. So the answer I'm expecting from you is that in which sequence you will turn on, let's say this negative bus you have directly connected. Okay. In what sequence you will turn on S1, S2? This is first question. Second question is, how do you set this voltage and current limits on your DC power supply? Okay. Can one of you quickly, so that we can discuss this further? Will you turn on switch S2 first? Will you put any component here in between? Do you need it? That kind of analysis. And how do you set this voltage? At what voltage you're going to set? What current you're going to set? Can you quickly help me on this? Again, I'm quickly checking. Am I audible?
Yes, you are audible. Please answer, participants.
Yeah, whatever comes to your mind, please answer. One important discussion most probably will come out. That's what I'm trying to figure out. Something generally we neglect at student level, and that may damage your DC power supply also. That is what I'm trying to figure out. Okay. So tell me how you're going to do this. Very simple, right? Better you know DC power supply, you know how you're going to charge it. Anyone? There is no grading
Sir,
involved, right? Yeah.
Yes, sir. So, like initially during charging, like battery will be like, if I'm not wrong, will draw a huge interest current. So the sequence of turn on will be like initially we have to turn on S1, and from the DC power supply, since like we can adjust like means in DC power supply we can set the maximum current to be drawn, and after that in between like we can put some converters so that it will match your battery voltage, and then
Problem
like
is that there is
turn
no
on
converter.
switches.
Converter is not there. Okay. let us make your life easy. Let's say converter is not there.
Then
You have
like
DC power
initially
supply. Why you
turning
need
on.
a converter?
Okay, sir. Then like
Achha,
turning on S1
sorry
first.
to interrupt. Huh? Let us assume that the battery
That,
initial voltage is 11 volt. Okay, to make our more specific, it was battery initial voltage is 11 volt. Okay, now tell me how you're going to set this voltage and current limit, and in what sequence you will turn on S1 and S2.
Sir, first we turn on S1
Mm-hmm.
and put the set the power supply voltage at 11 volt. Then
Mm-hmm.
gradually, slowly increase the voltage till the constant current. We can get a certain current at which we have to charge.
So basically, you mean to say till the battery charge for 6-7 hours, you will be near the DC power supply and manually changing it?
No,
This is not
set
the
it for
idea.
1 ampere or whatever a certain ampere
Mm-hmm.
rating is there
Now,
for
but you
that.
said initially you'll set at 11 volt, right? Now, please note that to go from 11 to 14 volt, it may take 4-5 hours to completely charge it. So what I'm saying, you cannot be near the DC power supply for such a long time. You have to think about a solution. You set it, you forget about it, battery will automatically get charged. Some sort of that solution. Is that clear or did I confuse you? Yeah, maybe some of the participants are afraid that if they give answer, I will counter attack them. Please feel free to say anything. It is absolutely, you are welcome. In fact, I have burned one DC power supply. That's what I'm saying you this. Absolutely no issues if you give wrong answer. But I request you to speak up. Say something, whatever you feel like.
You can guess any values because you have to just justify your answer. If it is not correct, then definitely it will be told that why it is not correct and how you should decide. So at least you should speak up, all the participants. Maybe Rahul or Dennis, you can answer.
Yes, sir.
Sir, after
So,
getting fully charged, it will get it. The battery voltage become 14 volt. So we can set this DC supply voltage to 14 volt.
Mm-hmm.
So it will charge till the 14 volt, and when the potential difference between these two ends becomes equal, then it automatically stops.
And current limit you'll set at what value?
Sir, current value depend on the battery resistance, the current value.
But for every battery, there will be a limit, right? Till what you can charge or what maximum current you can charge with. That's what we are referring. Maybe a C by 10 rating could be good for lead acid batteries, which gives you roughly 1 ampere of maximum current for that CC mode, right?
Yes.
Yeah. So yeah, you're to the point. Now let me tell you why I told you all the story. Generally, some of the student what mistake they do. In fact, I also most probably I did that mistake long back. They very sure about this switching arrangement. First of all, some of them may forget to turn on S1. Some of them may forget to set this voltage limit first. Okay. Some of them may directly connect this one to this DC power supply. Now, main problem with this approach is that any DC power supply, linear or this, right, they will have a capacitor at the output side. Most of them. Okay. Basically, they will take 230-volt AC power supply from the input, single phase, and they will convert it into your required voltage based on that knob. Okay, 0 to 32 volt, whatever you set it. Now sometime before you turn on this power supply, this capacitor will be totally discharged, right? And for uh, for a simple logic, Now, if you connect your battery directly to it without turning on the power supply, there is a high chance that your 11 volt, whatever it is, it will simply short circuit the capacitor, and there is a high chance of damaging this capacitor and maybe some other component also, right? So this is why I said you have to be very careful on this particular aspect. Ensure that there won't be any backflow of current to the DC power supply. Now, most of us, we don't think about this because we think the DC power supply is always available for giving something. It cannot take something. Most of the DC power supply, in fact, if you do this arrangement, they may get damaged. Okay, so be very careful on this aspect. First, turn on this power supply and make sure that you have already set this voltage to around 11 or more, at least 12 or something to begin it. Of course, you can set directly at 14 volt, no issue. So as soon as you set it at 14 volt, and let's say this switch S2 is open. So in your display, it will show 14 volt, 0 ampere. Because there is no load connected, but this output terminal, you will see 14 volt. Now you should set your current limit, and as we discussed, maybe 1 ampere of current limit should be good enough. So as soon as you put a current limit of 1 ampere, then you turn on this S2, right? So your DC power supply, it was trying to maintain 14 volt at the output, and suddenly you have connected a 11 volt battery. This is a capacitor, of course, 11 volt. So it will try to charge this battery with this much of difference voltage. So 14 by 11 by very small internal resistance of the battery. As a result, your current will have a tendency to go up. And as soon as it reaches 1 ampere of current, the current limit feature of the supply will get active. So at a time, one of the voltage or current limit will be active in DC power supply. Both of them cannot be done simultaneously. Those who are familiar with this, you must be knowing this. So when you are controlling the voltage, basically it will be in voltage control mode. But as soon as the current that you are trying to draw try to become more than your set limit, it will enter into current control mode. And basically to flow 1 ampere of current, so you need 11 volt plus 1 ampere into R internal resistance of the battery. That could be maybe 11.2 volt or 11.5 volt, something like that. So your display now you will see around 11.5 volt, 1 ampere. And this is actually current limit now. So at 1 ampere, it will start charging the battery, and slowly this voltage will build up. It will take time. And finally, once it becomes near about 14 or let's say 14.2, 14.5, then charging will stop automatically. So you need not be there near the battery, and that's how this entire process will be over. So just set one time carefully, and you don't need any other component. Sometimes people use a resistor for reducing the current, etc. But then basically you are losing some power. That is not required if you carefully select this voltage and current limits. That is what I try to show you. Especially, please take care. Do not damage your DC power supply. Otherwise, your faculty will be angry. And believe me, just purchasing something and getting fund for it, going through all these official formalities takes a lot of time. And if something goes wrong, it is even difficult to repair it. You have to run behind the vendors. All the faculties here, I think, if you're listening to this, you must be smart. You know this. And you have to run behind the vendor. You have to send your DC power supply to them, and getting it repaired takes a lot of time and effort. So please be careful. So we'll take a quick case study. For electric three-wheeler, as I was mentioning, there are total 4 number of batteries, each 12 volt 100 ampere hour, and that's how it becomes 48 volt 100 ampere hour battery. Now, so if you multiply this voltage into current, so basically 48 into 100 VAH, right? VA basically becomes watt, and this is approximately, let's say 5. 1000, so 5 kilowatt hour. So this is the capacity of this battery pack approximately. Okay. Now, you know, when battery is fully charged, it will actually go up to maybe volt, something like this. So to take a round figure, I took it 5 kilowatt hour. Now, does it mean that you will be able to take out entire 5 kilowatt of energy from the battery? It's a big no, because there is a concept called depth of discharge. Typically, lead acid battery will allow around 50% or maybe slightly here and there. So what does it mean? Even though you have a battery capacity of 5 kilowatt hour, you won't be able to utilize the entire of this capacity, right? So hardly 50% is maybe usable. Whereas for lithium ion, you can get maybe 80%, 90% depth of discharge. So that means most of its capacity you will be able to utilize. So effectively, a lesser capacity pack for lithium ion battery may be sufficient as compared to lead acid battery. And also a lead acid battery you will be able to charge slowly, that we discussed, typically 10, whereas C by 2 is quite common for lithium ion batteries. It can charge for C rating also. Now, typically the chargers that are available in Indian market, these are rated for 56 volt, because 48 volt is the nominal battery voltage. Fully charged 54, 56 volt. So it must be rated for that voltage. And typically 10 ampere. Why 10? Because ampere hour is 100. So C by 10, roughly 10 ampere. Some chargers are already also available for 15 ampere rating. These are commonly available charger in Indian market. So hardly 500 watt to 1.5 kilowatt. Okay, and charging takes typically 6 to 8 hours. Now I'll give you a task. Please pay attention again. Let's say if I had used a lithium ion battery instead. So 48 volt, 100 ampere hour lithium ion. Now you would agree that we may not need 100 ampere hour of lithium ion, because it's if you want to make one-to-one comparison with the lead acid battery, maybe a 48 volt 80 ampere hour would be good enough, because its depth of discharge is more. You can take out more juice from the battery, right, as compared to lead acid. But to make our calculation easier, let's say 48 volt 100 ampere hour lithium ion battery we are talking about, and it has capacity to charge at C rate. So that means you can charge it at 100 ampere, okay, and you can charge it within 1 hour, right? That is the C rate. So 100 ampere you charge in 1 hour, you will be able to completely charge the battery. That is the simple math, though there are some changes here and there. Now my question to you is very simple. Let me take a separate slide. Please pay attention here. This is very important point I'm going to discuss. Now, let's say this is your challenge. 48 volt, 100 ampere should be your battery charger output. In practice, it should be around 56 ampere because, 56 volt. So what is the power rating you need? 56 into 100, okay? So 5.6 kilowatt battery charger. Now, my question to you is that, let's say you are designing this charger for India and for your home. That means for domestic use. Okay. Our context is very clear. Indian context, domestic use. That means in your house, what do you have? 230 volt single phase supply, right? 230 volt, 50 hertz single phase supply. So the question is, for your home, can you design a charger of 5.6 kilowatt? Is it yes or no? Can I have your answer? Whatever you think like. Can I design a charger who can give me 5.6 kilowatt at the output? Is it yes or no? Any answer quickly?
No, sir. No, sir.
No. Why?
So because of there is a current limit of 16 ampere only, no? Hello.
think he's disconnected. Hello.
सिग्नल ब्रेक हो गया लग रहा है.
Hello, am I audible?
Yes,
Yeah, so-
now you're audible, sir. In between there was some break.
Yeah, basically there is a power cut, surprisingly.
Oh,
Generally in IITs you don't see power cut, but I'm unfortunate most likely. So yeah, let me turn off the video. It does not have any meaning now. Okay, I'm going back. I'm connecting through my mobile hotspot. Hope you can still hear me properly. So some of you said I cannot design a 5.6 kilowatt charger for domestic use, and you said it is no. Why is that?
Sir, because there's a limit of 16 ampere in single phase supply.
Okay, that's pretty good answer. So how much maximum we can design with?
So it means 230.
230 into?
16.
Okay, that's all.
Yes, sir.
Okay, there are two factors you are missing. Can you or any of your friends can think about? Two important factors you are missing. Remember, when we say rating of something, do you mention input thing or output thing? Output, right? Huh? Let's say 5 kilowatt motor. Does it mean the motor has maximum capacity of 5 kilowatt at the input side or output side?
Output side.
Exactly. So most of the product, they are defined how much they are able to deliver, right? So I hope I gave you a hint about one of the factor. Two factor you missed. That's what I said. This is the input. Finally, this is your battery charger. And this is your output. At output, how much you'll be able to give? That is the question. What is the rating of that charger? Is it 230 into 16?
Into root 2, it will be.
Into root 2. Why is that?
So it is maximum power it will be delivering.
No, I think you are going in a wrong direction. See, this 230 is the RMS value, right? In any AC system, what is this power? It is nothing but VI
cos phi.
cos phi, right? This V is I, this VI, these are all RMS values. So put it 230, sorry, 230, current, let's say 16. Sometime you have 15 ampere plug also. Let's say 16 is also fine. Cos phi, how much maximum you can have?
0.95.
0.9.
Yeah, it depends on what kind of battery charger you are designing. I'll show you later on some interesting waveform that I captured at IIT Kharagpur lab. Okay, so it depends on what AC/DC converter you are using, what is their power factor. Ideally, I want to achieve this power factor as close as 1, right? That's how I optimize on the or increase the power rating. So my target is to achieve 1. Now, let's say it is 1, or maybe you make it say 0.98 or something, right? And I'll show you some cases where this can be even 0.8, 0.7, something like that. Okay, so that's how we have to be very careful on this small details. So what is the maximum input power we can have? 230 into 16 into, let's say 1. This is for power factor. Okay, ideal case. So this is how much. Can one of you quickly give me the number?
3680.
3680. Okay, this is the maximum input power. do you think at the output you will get same amount of power?
No, sir. Means like based on the converter efficiency, you'll be like getting less than this.
So typically, what do you expect this converter? What efficiency figure it would have? %, 60%, 80%, 90%, roughly. What do you think?
Sir, if the efficiency is like good ideal condition, then we can take 0.9 to 0.95.
Okay. So typically, let's say 0.9. Okay, because later on I'll show you that it actually has two number of stages. So let's say 0.9. So can you give me this number? Finally, what could be my maximum output power? So this into 0.9, right? What is this number?
3312.
3312. Okay. That's why you will see most of this domestic charger maximum power rating is typically 3.3 kilowatt. I think now you will be able to correlate more. Okay, typically 3 to 3.3 kilowatt is the maximum power rating of your domestic appliances, because your plug or the socket rating is limited to 16 ampere. Okay, and your typical voltage rating is 230 volt. So that's why even if your lithium ion battery can consume higher power or higher energy or higher current, our domestic level power socket, etc., they are not designed for it. Okay, so logically you should not design a charger having more than 3.3 kilowatt power rating. Okay, so again, quick revision. What we understood, for domestic level uses we can use maximum 3.3 kilowatt charger. Now I'm going back one step, and remember, for e-rickshaw we use 48 volt 100 ampere hour lead acid battery. Should I use 3.3 kilowatt charger to charge this battery? What do you think quickly? I repeat the question.
Yes, sir. Yes,
I
sir.
Yeah, okay, you said yes. How do you justify your answer?
Because sir, we can use this 3.3 kilowatt charger. We get less current than 100 ampere.
Okay, but here is a catch you are missing. We discussed few minutes back. Lead acid battery can be charged typically at C/10 rate. Most of them. Okay.
Okay, sir. I didn't.
Okay. So the maximum you can charge it typically 10 ampere to 15 ampere. Generally not beyond that. Maximum 20 ampere. So take the number. Instead of 48, you take it 50 for ease of calculation, and 20 ampere. Maximum. How much? 1000 watt. Okay. 15 to 10. How much? Hardly 500 watt. Okay, so even though you had capacity to use a 3.3 kilowatt charger, you should not use it for charging the lead acid battery of e-rickshaw. Mostly it will damage your battery and there may be fire incidents. Okay, and then people will blame the lead acid battery, but that poor guy had no mistake. It is our mistake to charge it with higher current. Okay, so this is very important to correlate all these dots. Next, another important point, quickly, let me take you. Yeah, again, please pay attention, very important question. Let's say we talk, okay, I think power is back. We talk about lithium ion batteries and we understood, again, we'll take an example, 48 volt, 100 ampere hour battery. Let's say it can charge at C/2 rate, maximum. which is 50 ampere. Okay. Now, all of you, I want to think about a situation. What is that? Let's say you have a two-wheeler. You have driven the two-wheeler, let's say for 30 minutes continuously. Okay. And battery is more or less discharged. Either fully discharged or close to that value. Okay. And let's say this time is, I don't know what is the time right now. It is in my watch. It is 8:11 p.m. Okay. And then you came back to home. You plug in your charger. Maybe it will take 30 seconds, let's say. And at roughly 8:12 p.m., you connected with the charger and you want to charge it with 50 ampere of current. Okay, this is the situation. I hope you got the timeline and everything. So do you think it is a good idea? Any one of you, can you quickly answer? If you have any doubt about the situation, let me know. Maybe I'll quickly reiterate the statement. You had a two-wheeler, you drove it for 30 minutes continuously, and battery is more or less quite close to discharge condition. You came back to your home, instantly you have plugged in the charger, and you want to charge it with full current at CC mode. Do you think it is an advisable or good idea?
Sir, if at all the battery switch, which is having some pre-charger kind of thing and a pre-charge resistor, then it is fine. If at all it is like having means low side contactor or something like that, which doesn't have a pre-charge, then it is not a wise idea.
No, but see, in your what do you say? In your battery charger, there will always be a current limit, isn't it? Be it pre-charger or not, more or less there will be having a current limit.
Okay.
And pre-charger also, most of the batteries will have. Battery charger, most of them practically would have it for preventing that inrush current. So let's say all these features are there. Maximum current you can draw is 50 ampere. Pre-charge is not a problem. Then still, is it a good idea? A safe idea?
No, sir.
Why?
Sir, as we discussed before, means it was having if we will charge, then it will be charged by 3.3 kilowatt, and our battery power is 2.4 kilowatt. So if means it is less power, so it may damage.
No, but there is a current limit in your charger, right?
Yes.
So battery charger is charging at 50 ampere also. 50 ampere only. So you're not pumping more current in the battery than its limit. So let's say you have a 2.2 kilowatt charger, no issues. Then what do you think? Okay, now let me tell you the story why I ask you this. You have to remember a very important point here. When you are charging a battery, okay, the temperature of the battery, typically lithium ion battery I'm talking about, okay, should be less than 45 degrees centigrade. Typically, okay, it may vary manufacturer to manufacturer, but these are typical numbers. This is charging. But when you are discharging, allowable temperature could be maximum less than equal to 60 degree or 65. So what is the summary? When you are discharging the battery, you actually can have higher temperature limit without damaging the battery. But when you are charging the battery, your temperature of the battery should be within typically 45 degrees centigrade. Okay. This is the catch. That's why several people don't understand this. Whenever you buy any electric vehicle, the shopkeeper will tell you, when you came back from driving your vehicle, please do not put it on charger. wait for some time, then you do it. Why? Because when you are discharging, there is a high chance that battery temperature was around 60 degrees centigrade. Now you should wait for the temperature to go down from 60 degree to 45 or low before you plug in your charger, because most of the chargers does not take care of all these issues. These are simply some imported charger or some low cost charger who does not know about all these details. Okay, so I repeat, you come back and there is a high chance that when you stopped, when you came back to your home, the battery temperature was internal maybe 60 degree, which is allowable, but during discharging, not charging. Now at this 60 degree temperature, if you had started charging the vehicle, there is a high chance that it will catch fire. And that's why maybe some parking station, etc., you hear that some fire has come up. This is one of the strong reason, because most of the vehicle owner does not know this, and some of the chargers also do not take into consideration all these issues. They get battery from one manufacturer, charger from other manufacturer, and these are not properly compatible, right? Not certified, a lot of issues. So I repeat, you come back to your home, there is a high chance battery temperature is on the higher side, which is not suitable to be to start your charging process. Okay, so you wait for some time, so then slowly temperature will go down because you are not discharging the battery anymore. Definitely battery temperature will go down. Then after 10 minutes, 15 minutes or half an hour, then when temperature is less than 45 degree, then you can start charging your vehicle. Okay, please do not ever start charging as soon as you stop discharging or driving the vehicle. It can be very risky for you, for your vehicle, for your nearby person also. I hope I made this point clear. If you have any doubt, please let me know.
Sir, if there is a issue with temperature, then there should be temperature controls in charger also. It should detect the
Exactly.
temperature of the battery.
Yes. So that's
So
why
is
this
it not
high-end certified charger should have, but this low-cost local-made charger sometime or import, they don't have it. Ideally, what they
okay?
should have is that you have this temperature limit. Now even if you even if the see customer are not electricians or electrical engineers, right, or rather engineer, so they may
Yes, sir.
plug in. So what your battery charger should keep a eye on the temperature.
Correct.
So as soon as it sees temperature more than 45 degree, it should not charge CC mode. It should wait for some time, right? Then it should go into CC.
Okay.
That is
So,
the catch.
sir, one more thing may also be there. So it
Mhm.
means vehicle should have a temperature indicator, and customer should know that if temperature is above this limit, it should you should not charge it from any charger.
Exactly. But do you get any such indication in the two-wheeler or three-wheeler you are driving?
No, sir, it is not there, but I think it should be because it is a coming major problem because of it.
Exactly. That's why people like you should contribute, right? Solve out all these
Okay,
problems.
sir.
What we did in our
Thank you, sir.
product that I showcased few minutes back, we have a temperature sensor in the battery, temperature sensor in the motor, temperature sensor in the motor controller, etc. So as soon as we see some temperature is going up, we always restrict the operation so that safety can be, improved, enhanced. Okay, I think this point is clear. Dr. Shailendra, I think I have been talking so for a long time. Maybe they're feeling bored. Shall we take break or what do you suggest? Or
Yeah, sure. We can have 5 minute break and then we shall start. Thank you, sir.
yeah. Let me not torture them continuously. Let give a 5 minutes break. Yeah,
Stop
thank you.
trying novel, sir. I think I feel
But you are not the student or you are not the participants.
no, but it's quite interesting because we are dealing with the issues which are happening in currently in the two-wheeler or three-wheeler. So really it is a very interesting talk. How we can charge the battery. Few basic things we have to keep in mind, and then we can go for the charging the charge.
Yeah.
I mean, but it is like I said, everybody takes interest in the story, in listening the story.
Yeah. Hopefully. Yeah, so we are taking 5 minutes break, but in between any participant, if you have any question, I'll be happy to answer. Then maybe we'll start at resuming the main content at 8:25. If you have any question, you can feel free to ask. It can be any general question also, no issues, non-technical things.
So I have only just a query about Ola scooters catching fire. So this is the main reason we are talking about of that failure or something else?
No. This thing is that I cannot talk about any particular brand. I hope you understand those issues. I'm talking in general. Okay, this can be one of the main reason. This can be.
Okay. Okay, sir.
I have a question to Dr. Shailendra. So, in your department in power electronics area, typically in which topic you are right now focusing on? Of course, you need not disclose the exact problem statement. The overall broad area. You are
Sir, currently, myself as well as using, we are having a team like that we are also targeting to develop this EP lab. So,
mhm.
I mean, we have these battery chargers, but right now we are dealing with tap converter as well as these battery.
Okay.
Currently, I have developed one green integrated like battery. I have integrated with the solar PV array simulator. Obviously, the deep space controller. So, not till now gone the that development as you have developed these sensors. But yes, prototype we have developed in our laboratory. We have verified charging discharging like vehicle to grid and electric vehicle. And sir is dealing with the electric vehicle also, and he has developed this charge controller, multi-port converters. One of his basic is also. Only actually, I mean, in 2020, I have joined this institute. So
Mhm.
during these 2 years, we have purchased lots of equipment, and then we are starting.
Wow, that is really good to hear. Thank you.
In the cost of your charger.
Yeah, Dr. Shailendra, I'm sorry, your voice is quite breaking now. I cannot make out these sentences.
Yeah. Hello.
Yeah, I can hear you now. Though it
Yeah.
is not very clear, but still okay. Yeah, please go ahead.
Yeah. Actually, sir, we want to take your help during developing of these chargers. So I don't know. Can we buy this charger from you, or how we can collaborate? Actually, help in this regard, because these vehicles we are also looking to develop in our lab.
Mhm. Yeah, to be honest, I started this battery charger work. In fact, still some of our colleagues and collaborative work is going on. But as of now, I'm more focused on different motor and motor controllers.
Yes.
And yeah, if you are interested, we can discuss at more length separately. And if you have any good student team also, then of course we can collaborate and we can see how we can start
Yes.
doing something together.
Yeah. Actually, I have also purchased one synchronous reluctance meter in the motor, and we are
Okay.
Completed the preparation work.
Mhm. Okay. Glad to hear that. I recently we've completed design of a synchronous reluctance motor and we gave it for manufacturing. So maybe in 1 month time I'll get a new our own designed synchronous reluctance motor in the lab, hopefully.
Yeah.
So you have some students working on the controller for this motor?
Yes, sir.
Okay, okay, that is great. I have one dual degree student working on it. Maybe then we can talk separately. Yeah.
Yeah.
Okay, so it is 8:26 now. Maybe I can resume and we'll wind up by 9, right?
Yes,
Or
sir.
what is the plan?
Yes, yes. We'll wind up by 9.
And sorry. And during the interaction session, what do you do as you mentioned in the schedule?
Actually, we have a few queries if anybody is having at the end, and we plan for the next day also, and we discuss those things with the participants.
Okay, okay, fine. So I'll try to wind up by 9, maybe 5-10 minutes here and there. And
Yeah, no
yeah,
issues.
maybe for some question and answer if is. So next, what I'm going to take you is, let me, I don't know, did I open this? Quickly, let me tell you, let me take you to a market survey rather. Yeah. Please let me know once you see my this Excel file.
Yes, sir.
Yes, it is visible.
Okay, okay. So if you wish, if any student you need this data, I'll be happy to share. No issues, right? So what I'm trying to tell you, if you look at the two-wheeler segment in India, typically Ather and Ola, they are leading now. And you can see most of them are using lithium-ion batteries. You can see here. And you can look at what is their rating of the battery they're being used. So mostly it is either 60 or 48 volt. Only Revolt is using 72. Generally, when you go with slightly higher power, you want to increase your voltage level also. So two-wheeler, typically when the vehicle price is more than 70-80,000, typically more or less they will be using lithium or its allied battery technology. And 50,000 or less, typically they will go with lead acid. I personally have a electric two-wheeler, which is a brand called Ajanta. Most of you must be knowing this brand. You might have used the watches by Ajanta. So Ajanta actually has a electric scooter which goes by the brand called Oriva, Oreva. So I'm having that two-wheeler in as my personal capacity, and that actually uses lead acid battery. And these are 24 volt and around 30 ampere hour battery. That is what they use. So here, what I'm showing you, most of these popular two-wheelers in India, they are using lithium-ion batteries. You can see different battery pack voltages, their current rating, etc. You can also study if you're interested how much motor power rating they're using, what is their top speed, etc. So why I'm telling you all this is that you can get a clear picture of different ratings because you need to know about these numbers also. Then electric three-wheeler more or less I discussed, so I did not put much thing here. If you look at,
Excuse me, sir.
yeah, please go ahead.
The this Excel file is not visible to us.
Oh,
No, it is visible, sir.
I have shared the entire screen. I think it should
Paramjit,
be.
refresh it or again log in. Maybe sometimes it
Okay.
stores the old value, but I'm able to see both the Excel files.
Okay, sir. Okay.
So it is visible to most of the candidates. You can just refresh it.
Mhm. And electric two-wheelers, mostly you will see slightly rating of less than 1 kilowatt. Typically, they go with the hub motor, and beyond that, they use something called mid drive. Basically, they put the motor in the mid of the vehicle, and thereby through belt and chain drive, they connect it to the rear wheel. If you look at four-wheeler category, presently Nexon EV is the most selling vehicle in Indian market. So more or less everyone is using lithium ion or lithium polymer. Tata Nexon is using lithium ion battery. Battery pack is 30 kilowatt approximately. Battery nominal voltage is 320 volt. Okay, because a motor they are using is also pretty high. Maximum power rating is around 95 kilowatt. So for such a high rated motor, definitely you need higher voltage. Otherwise your current will be too high. So 32 volt, 320 volt is the nominal for Tata Nexon EV, and battery capacity, pack capacity is 30 kilowatt. And typically they can go 90% depth of discharge. And they're using PMSM motor, as you can see. Similarly, you can study other battery voltages, but more or less everyone is using lithium based uh, batteries. And if you look at the market survey of most popular EVs around the world, right? Maybe Tesla's model, Nissan Leaf, Hyundai, etc. So there also, if you look at the battery pack, look at this one. More or less lithium ion is the first choice. You can also have a look at the battery capacity and different other things. So either what I suggest is that if you are interested in this EV category, please try to prepare an Excel file like this or similar, right? And get a clear idea what motor they're using, what power rating they're using, what is the torque rating, what is the battery capacity, etc. If you don't have time, you can also write to me. I'll be happy to share this Excel file, because if one of you get benefited, I'll be happy. So now let me get back to the slides again. This, I think right now what I showed, so I'm not going to ask you. Mostly the four-wheelers are using lithium ion battery. Three-wheelers are using lead acid at present, but they're also shifting towards lithium ion. Two-wheelers mostly using lithium ion. Some of the low-range drives are also using lead acid batteries. Now we talked about few batteries. Quickly we'll discuss about the battery charger also, some part. Okay. Now, how can you charge the batteries? There are various options. I'll quickly touch upon few of them. One is conductive charge, which is very easy to understand. So you have a charger, you have a connector gun, okay, and then in the battery, in the vehicle, you put it and you start the vehicle. So basically, it's a wired charger. Another option is, of course, wireless charger. It is an example I'm giving is an inductive wireless charging. Present day, they're also doing capacitive wireless charging and sometimes hybrid. Okay, this is still a very interesting area. And this wireless charging can be of two type. One is static. Basically, you're having vehicle parked, it is not moving. You have static. You can also have dynamic. So basically, your vehicle is moving on road, and at the same time, it is getting charged wirelessly. So that is the dynamic kind of charging on road. And next category is battery swapping. Very straightforward. You go to a swapping station, you hand over your discharged batteries and get a new battery. And it is very fast, of course. But for very big vehicles, this is still a challenge. Two-wheelers, three-wheelers, they have started implementing it. In fact, you might have seen news as Indian Oil tying up with several companies, and they also have started it. And also there is, in this conductive category, a new update is flash charger, which is one of them is being developed by ABB. They've already deployed in some countries like Sweden, if I remember correctly, and in Australia also they're planning. So basically, they will charge. These are mainly for big buses or big category of vehicles. So whenever the buses is plying on city and there is a stop, they are basically quickly charging the battery, and that's how frequently they are charging it, right? Because bus stops may not be long in city drive conditions. So you can reduce your battery rating requirement because you are frequently charging, but your converter has to be designed so that it can charge the battery very quickly for a short time, right? There are of course several challenges and very interesting research problem in this area. You can study more about this flash charging. Okay, very interesting concept. This I'll quickly skip, not much thing. Now this also I'll quickly skip. This again I said I will be sharing you with the slides. Okay, so different component, different level of charging, especially in Indian context, what power rating the government is trying to set, all these different category of charging, fast, slow level, all the specification I have mentioned. You can also go through this website for more details to know about more about Indian standards. And then you please spend some time understanding these connectors. Very interesting. Different vehicle use different connectors, right? And what are those pins, how they communicate with the vehicle. So for example, let's say you want to design a charger which will be able to charge let's say 5 different category of vehicles. Let's say all four-wheeler, but let's say one is from Tata Nexon, one is from let's say Hyundai, one is let's say Nissan. Okay, now all of them will be using different battery pack voltage. Their battery chemistry may be slightly different. Their charging rate may be different, right? So how do you design a charger which can cater to all these different category of vehicles? So it must know what is the battery voltage level, maximum current it can charge with. So in short, it must communicate with your battery, right? Now this communication, either it can be done through present day new updates like CAN bus, where they talk to each other and then determine what is the battery voltage, what maximum current it can charge, whether vehicle is moving or not, right? As soon as you put in the charger plug, your vehicle must stop moving. So all this protection you must ensure. So present day they are being done with different communication medium like CAN communication. But if you want to understand a very simplistic arrangement, okay, without going into all this communication details, just study this particular connector. Again, I'll be sharing the slides so you will get all these details. If you have any doubt, you can later on, you can also communicate with me. So if you look typically this kind of charger, this connector gun will have total 5 number of pins. 2 of them are actually for power lines and one will be dedicatedly connected to ground. Another is control pilot, another is proximity detection. Proximity detection basically senses whether a charger is connected to the car so that car stops movement, right? And control pilot is basically a way of communicating through this particular pin. The charger communicates with the battery and they understand how much, what is the maximum current with which it can charge. And all this information, right, very interestingly, it can be done with simple resistor divider and some low cost simple arrangement. So due to shortage of time, let me not go into the detail. I have made the slides, it is slightly longer, but if you go through it, a lot of statements I have added so that you can, you know, if you read them, you will get more or less the understanding of it. So let me skip through it. Now, next step is that let us quickly in next 20 minutes, I'll give you a short intro about the different chargers or rather a sample charger for let's say e-rickshaw or two-wheeler applications, which can be of course extended to four-wheeler, no problem. Now, when you charge the designer charger, you would expect that your AC voltage will be 230 volt, right? So do you really design your charger to be compatible with 230 volt or you provide some range? Sorry, that is the question. Okay. I know in India 230 volt is the typical standard, right? But if you go different part of the country, you will see that sometime it can go to 230, 240, 250 also during some extreme conditions. Sometimes voltage can be as low as 150, 100, etc. also. Okay. So universally, when these chargers are designed, they are designed such a way that they are able to cater this particular segment. So your whatever charger you are designing, it's not only able to operate at 230, but you should also offer a range. Okay. And typically this is the range, universal range. 95 to 265, it must be capable of operating. Okay. Then your input is AC. Definitely you need a AC to DC converter because your battery is DC. Now here I am going to tell you again an interesting story. Please pay attention. I'm sure you will get some interesting concept here. So this we have already discussed. I'll skip. Yeah. Please pay attention. This is a voltage waveform. Okay. And where is it captured? It was captured in one of our lab, first year electrical technology lab at IIT Kharagpur. Okay. How did I capture? Basically, you know, oscilloscopes are there, digital storage oscilloscope or other oscilloscope. You can see the voltage waveform in real time. So I connected a voltage waveform, and this is how I got the voltage waveform. Now, when we study first year, typically we study this voltage waveform will be Vm sin omega t, right? So Vm will be 325 and sine 2 pi 50 t. Okay. Why 325? It is nothing but 230 into root 2. 50 is your frequency in hertz. Okay. This is what you expect. Now, can you tell me whether this is exactly same? If not, where it is deviating? Can one of you quickly point out? First of all, is it a pure sine wave? Yes or no?
No.
No, it is not a pure sine.
Where it is deviating most?
Negative side.
Flat top.
Right. Thank you. So ideally, I would have expected something like this, right? But what practically I'm getting is this kind of flat top. Okay, is there anyone who, from the student side? Of course, I know most of the faculties know it already. Some of the students also know it, I hope. Can you give me a reason why this is happening? And let me tell you, this is very prominent in educational institutes. If there is no corrective action taken, most likely that in your lab also you'll get similar thing. If there is no specific care that has been taken to solve this, you may get this kind of waveform. Any idea, anyone? Okay, due to shortage of time, sorry, I am not allowing you to speak much. Now I'll quickly tell you the reason and we'll wind up one particular story. Typically, see the Indian power grid, if you look at, right? Now, of course, we have a central grid which connects most the entire country. Now, let's say I am here at IIT Kharagpur or right now IIT Delhi. So all these loads are connected in parallel in my home, right? Or in my lab. This is the point of common coupling. And then generally there will be the power plant. The distance between the power plant and our lab will be thousands of kilometers, right? Generally big power plants are located in rural areas or areas where not much population is there. And of course, there will be in between some transformer for stepping up, stepping down, and so on and so forth. So if you want to show it simplistically, typically you have this power plant, then the transmission line impedance equivalent, and then you are sitting here with all this parallel connected load. Okay. Now, let us take an example. If these are the linear loads, right, which are drawing very sinusoidal amount of current, not a big issue. This problem won't come. But let us take an example of rectifier. Okay, Most of you have already studied full bridge rectifier. I am very sure about it. So I am not going into much detail. So you know that a full bridge rectifier, okay, if I don't use any capacitor, the output waveform will be like this dashed kind of waveform. Half wave, sine wave, half wave, sinusoidal shape, rectified waveform. Now, most of us won't like it because it has a lot of ripple. So we put a capacitor, right? And then the voltage waveform gets modified something like this. And we are very happy because now more or less we have got a flat DC. If I want to reduce ripple, I increase capacitor size. Okay, and that's how I'm happy. And you will understand this kind of rectifiers are required in your battery chargers. So whatever smartphone you are having, the SMPS that you have in your computer, laptop charger, everywhere this circuit may be present. Okay. Now doing this, what I'm creating a problem for the grid. Let us try to understand it. Okay. I'll give you this waveforms also. Please study it in your free time. If you draw this source current waveform, okay, carefully. For this scenario, your output voltage is like this. If you draw the input current waveform, you will see that your input current waveform looks something like this. It may not be exactly accurate, but time frame you try to understand. So this current exists only during peak of the supply voltage. Here you can see, right? And most of the time it is zero. Again, positive peak, negative peak, it is existing. How it is coming, spend some time, you will understand. Okay, just analyze full bridge rectifier with capacitive filter. Now, think about this kind of current waveform, when they will be drawn from grid, there will be voltage drop, right, in the transmission line. And most of the voltage drop will be appearing during this peak of the supply voltage, right? That's why even though your power plant is generating nice sinusoidal voltage, since there are some drop in the peak zone, why? Because of this kind of rectifiers, you are eventually getting this kind of waveform, okay, where this is flat. Now you can understand in educational institutions how many computers, how many laptop chargers are there, right? And how many smartphones are there. Even nowadays, students are very smart. They carry 2 to 3 smartphones, right? So this effect is very, very prominent in educational institutions. That's why I said, just try to see in your lab, maybe you'll end up seeing this kind of waveform. Okay. Now, again, another interesting story. I hope you understood more or less. Again, a detailed demonstration about this phenomena I have uploaded in my YouTube channel. If time permits, please watch that entire video. If you have any doubt, I think that will get clarified. With live demonstration, I showed you all this. Now, one important observation is that this same waveform, if you send to an inductor current becomes very nice sinusoidal waveform. Look at this inductor current waveform. Very close to very ideal sine wave. Though your voltage had this peaks, flat top zone. Same voltage waveform, when you send it to a capacitor currents gets more distorted. Okay. I hope you can see it clearly. Capacitor current is more distorted. Try to figure out what is the reason. That will form a very interesting basic concept regarding the filters. You know, capacitor inductors are used as filters. Sometimes resistances are also used. But in power electronic system, we deliberately try to avoid using extra resistance because of losses. So all these filter element generally you use inductor, capacitor. Now, if you can figure out what is the reason behind this, you will understand basic concept behind the filters and how you should place inductor and capacitor in your circuit to solve your harmonic related problem. Everything, a very strong base will come from this particular analysis. Okay. Please spend your time. If required, please visit my YouTube channel and locate this particular video. This is the title. Okay. And I'm sure you will get 2-3 new observations. So cutting long story short, what I'm trying to say is that if you use this kind of simple diode bridge rectifier as your rectifier stage for battery charger, there is a high chance that you will draw up this kind of current from the grid and your power factor will be definitely less than 1. Right? And what is the penalty? maximum power, remember we calculated that 230 into 16 into 1 because we assume our power factor is 1. But if you use this kind of diode bridge rectifier, your power factor is going to be less than 1 and your maximum power rating will be less than 3.3 kilowatt, obviously. Okay. That is one of the main problem. Another problem is you are actually creating trouble for the grid because you are injecting a lot of harmonics into the grid. Now there are a lot of grid standard. I have mentioned few of them in the slides. I'm not going to discuss in detail. If you're interested, go through them. So there are various countries that will say that the current that you're drawing from the grid or you are feeding the grid, they must have a THD, total harmonic distortion, less than typically 5%. Okay. Again, it varies your appliance category to category. Whatever domestic appliance you are using, that are generally classified into total 4 categories. Okay. Figure out in which category your charger will belong and what standard you have to use, right? And what is the harmonic limitation that you have to respect. So please spend some time on this. You will get a lot of interesting informations, and I hope this will help you in your research as well as in your job interview. Okay. Uh, so I think I'm left with 10 minutes, so I'll quickly finish it out. So till summary, what I try to show you is that in input side, we have 230 volt AC, definitely. Let's say finally I want 48 volt battery to be charged. So in between, I must have a AC to DC converter. Okay. Now I'll ask you a very simple question. This is one of the most commonly asked question in the interview. Okay. Just give me 2 minutes. So the question goes like this. You have a 230 volt AC supply. Okay. And you have used a diode bridge rectifier, full bridge rectifier. Sorry, the circuit is wrong. Simple full bridge diode rectifier. Okay. And this side you have connected a capacitor and then a load. So question goes like this. If it is 230 volt, what will be this voltage? This is definitely going to be a DC voltage. What is the voltage? So most of the students, they may come up with some idea like 2 Vm by pi, right? Or they will basically what they will do is maybe they will be taking this kind of waveform, then take the average. But as soon as you put a capacitor, you know, this waveform will get modified like this, right? So Vm by pi, 2 Vm by pi, these ready-made formulas are not valid anymore. So be careful on this, okay? This formula you cannot blindly apply. But now, even if you blindly apply, what will happen is that 230 volt, right? You will see that this voltage average value, if you forget about capacitor, will be around, let's say 207, if I remember correctly. Just do the calculation, right? Very straightforward. Take this voltage waveform, take the average, okay? And this will be around 207 or something like that. Just check it. Now, we want to charge a battery of 48 volt, okay? So definitely we need another DC-DC converter to reduce the voltage. Very straightforward. Another option, we could have used a transformer here. But this is going to be a low frequency transformer. Size will be more, weight will be more. Okay, generally people don't want to use low frequency transformer. So this approach of using simple diode bridge rectifier has 2-3 different problems, right? Especially in this power factor and efficiency side also. So to avoid this, ideally, I should have designed a rectifier which does not draw harmonics from the grid, right? So if this red color waveform is the grid voltage, I would have expected my battery grid current to be this blue colored waveform, which is sinusoidal, also in phase with the grid voltage, right? So that your power factor is close to 1. That should have been my ideal rectifier. So how do you get it? You use this diode bridge rectifier, but do not put a capacitor here. Put an inductor and a boost converter. Okay. And try to control this inductor current so that it has this kind of shape. And then this side you will get a rectified proper sinusoidal waveform. Again, this itself will take me 1 hour to explain all these things. Cutting short here. This is known as power factor correction rectifier. Okay, and some more version of this rectifier is also available. But problem with this kind of solution is that if your input is 230 volt, peak is 325, this voltage has to be greater than equal to 325. Practically, by keeping some margin, this voltage will be around 380 to 400. That is how we control it. Okay, and then on the secondary side, you must use a DC-DC converter. So typically your input is now 380 to 400. Okay. Again, a Viva question is coming up. Output is 48 volt. So you see your gain requirement, gain reduction rather, is approximately, I don't know, if you make it 50 to be fair of comparison, and 400, so 8 times. Okay, 8 times gain reduction you need. So if I ask this question to students during interview, they will say that yes, we can use a buck converter. Okay, because buck converter can reduce the voltage, but practically no one will use a buck converter. Okay, theoretically it is possible, practically also possible, but your efficiency will be very, very poor. Figure out, okay, if time permits, figure out why I said this. Maybe you can do some analysis also. Typically, when your gain requirement is high, more than 3-4, you generally go with isolated DC-DC converter. Some solution I have shown here. And how do you design them? There is a nice application note, which is there, I don't know, in some part of this slide, or I can share with you. Let me quickly tell you, because we don't have much time. Sorry for taking your time. Yeah, this link you please follow. You will understand all this, right? How to select this inductor, how to select this diode, how to estimate the losses, how to select the capacitor, and how to design DC-DC converter. Everything is mentioned here. In slide also I have mentioned. Okay. And quickly shifting towards, and then one prototype also we developed in the lab, as you can see. Just forget about this extra price spikes. This is coming due to noise picked up by the current probe. Practically, actually, it is not there. So you can see here what I demonstrated. I told you, right? If you use a simple diode bridge rectifier, how your current waveform looks like. See, there is a peak leveling at the voltage waveform, and your current looks like peaky during your peak of the supply voltage. But if you use this kind of rectifier, as I mentioned, power factor correction rectifier, your current becomes nice sinusoidal, practically. Okay. Quickly, I'll show you a simulation also. In case you're interested, drop me an email. I'll be sharing you the simulation model also. So this boost power factor rectifier I talked about you. See, this is the diode bridge rectifier part, and here is the boost converter part. Okay. And how did we control? It is there in this particular file. It is there in the PPT also. If you wish, I can share a earlier lecture recorded on the same topic, so that this explanation which I missed, you can go through those part also. Then on the secondary, second stage, we are doing a DC-DC converter here, isolated DC-DC converter, full bridge converter. And how did you control this? Basically using simple phase shifting kind of control, so that you can charge a 48 volt battery. And if you look at the current and voltage waveform, sorry, just give me 30 seconds. Yeah. So look at this. Yellow one is the voltage waveform. Okay. And this blue one is the current waveform. You can say quite nice sinusoidal. Of course, your power factor is not 1. And on the top side, you're seeing the DC bus voltage. As I told earlier, the DC bus voltage has to be higher than peak of the AC voltage. Now you figure out why this has to be there. If I reduce it, what will happen? All these things are very, very interesting concept. Please believe me, and spend some time. You will learn a lot of things in this area. Okay. So my time is up. I would like to wind up in next 2-3 minutes. This setup, I wanted to show you the dynamic wireless charging. It was taken from Dr. Regan Zain slides. So you can see basically on the road structure itself, they embed those primary side coil of the wireless charging, and another set of coils will be there inside your vehicle. And when vehicle is running, basically you will be able to charge it. So it's a very interesting area to work on. If you are interested, you can work in that. This is my last slide. Sorry, I'm speeding up a bit to save time. Now, what I try to show you is that if you look at these small problems and if you try to solve them, definitely you will come with some interesting outcome. Also, you can propose your new concepts, interesting other products, and come up with a startup. Okay. There are several incubation centers throughout India. Different IITs have, different industries also support. So come up with your own idea, apply for a startup grant, okay, form a good team, and there is a chance that one day you will also become a very famous entrepreneur and you will make us proud. Some of those, you can see this Ether Energy, right? It was actually, they were the alumni of IIT Madras. Look at this Ligar Mobility. Most likely they were IIT Delhi alumnus. Okay, so they did a lot of interesting product. Similarly, these are some of the startups in India which are doing pretty well. So I wish you all the best to all the faculties attending this course and all the students. Come up with new ideas, start your own startup, and someday become very famous so that we are very proud of you. Thank you very much for attending this course. If you have any question, I'll be happy to answer. Else, these are my email ID. Please drop an email ID if you want some collaboration work or some other discussion. Also, connect to me through LinkedIn. There I keep on posting our updates. And this is not the correct. My YouTube channel name is just search by Dipankar Debnath, IIT Kharagpur. And maybe you will find 2-3 interesting videos there. I'll keep few more in recent times. So thank you the organizing team for giving me this opportunity, and thank you the participants for bearing with me almost 2 hours. Okay, I know it has been a very tough journey for you. Yeah, I would like to wind up. Thank you very much.
Thank you very much, Dr. Dipankar. Now, any query, if any participant is having, we can have those queries.
I think everyone is feeling sleepy now. It was a very long session.
No, it was interesting, and they might have got many things out of this. Sometimes what happens, immediately students or participants, they do not react to the situation. But later on, because they have to go through these details, and finally they get good things out of these deliberations. So
and they also know if they raise any question, it will be lengthened. Yeah.
Is there any query? Anyone?
No, sir, it's very interesting and informative. Thank you.
No, sir. Thank you. That's very interesting.
Yes, sir. Thank you, sir. Thank you for the informative session.
Okay, so I hope if they have any queries, we'll let you know, and we'll try to get the answers for those queries. So from organizing team, our thanks are due to Dr. Dipankar Debnath, who has taken this pain to deliver a talk. He has discussed many things, starting from the battery to the charger and to the capacity calculations and many things. Because this, I think this was the required one for this FDP. And we had something in the series yesterday. There was a little bit of battery management, but not up to this level for the charging calculations. So thank you once again that you have delivered despite being at outstation, not at your home institute. And maybe you are still operating through your mobile data.
Yeah.
So thanks once again. And hopefully we'll have interaction. Maybe we'll meet somewhere in any of IITs, because definitely we'll encounter somewhere in the conferences. If you are coming to NIT Delhi for PyCon, we'll have some interaction there itself in the month of November, at the end of November, or in any other conference, or at your institute or our MANIT Bhopal. So we hope that this interaction would continue, and definitely we'll have more interactions, because we are also working in the similar lines. I had seen your vehicle, three-wheeler vehicle, and we are trying to have a laboratory setup like that also. So we have contacted few of the vendors, and if required, we'll talk to you separately from where you have got that hanging wheel and that driving environment in the laboratory, because it is very much important. If we want to develop something new, we should have at least one prototype which can give us the readings in the laboratory environment. Then we can try it on our actual system. So definitely we are planning the same way. So we'll have some collaborative initiations. Thank you very much.
Thank
And,
you. Thank you.
Yeah, Dr. Shailendra, if you want to sum up something.
Yeah, thank you, sir, for sparing time with us. And
please
it was
don't
very
call me sir. I
interesting.
think we are colleagues. Yeah, please go ahead.
Yeah, so it was, I mean, interesting as well as very informative, as some of the participants also praised this one. So yeah, sir, I'll talk to you regarding this controller. Actually, we have developed this controller, machine controller, and we are trying to incorporate with the DSP so that we can run this synchronous lectance machine.
Great.
So yeah, so that we can discuss, and sir, we can take the idea.
Okay. Yeah, we'll catch up offline.
Yeah, sure.
So then I can take a leave now.
Yes.
Sure. Thank you very much.
Sure,
Good
sir.
night.
Sure. Thank you very much.
Thank you.
Okay, so all the participants, hope this was a good session for all of you, because definitely from any of the discussions we have a lot many takeaways, and it depends on the person what you are taking out of those lectures. And we have recorded these sessions, so it will be available on YouTube. We will be posting it on a YouTube channel. So later on, if you want, you can even keep it with you, or you can download, and you can get benefited from these sessions. And regarding the papers, yesterday one more paper Dr. Shailendra has communicated to all the participants. So please go through that. And there is no hard and fast rule that which paper you are going to take, but you have to take two papers, and you have to prepare a summary of those papers, which I had already discussed yesterday. I'll share tomorrow the details about those summary formats for a reflection journal and the paper, and other things we'll have in the coming week. So we'll wind up today, and tomorrow's lecture shall be on the hydrogen fuel. So it will be on the electrolyzer hydrogen fuel and its application in the electric vehicles specifically, because that is going to be a promising fuel for electric vehicles, for the high-end electric vehicles, maybe trucks and buses and bigger vehicles, where you require a harder, you can say, energy requirement, which may or may not be sufficient from the battery many times. So we'll be discussing, and the expert speaker will be Dr. Sanjeev Dwivedi from Denmark. He was earlier working with the Danfoss drives, and you may be knowing about the Danfoss drives. They are a world leader in the drive area, and recently he has shifted to another company which is working in the hydrogen fuels. So we'll have interaction with him. tomorrow at the 7 p.m. So hope that all will be available at 7 p.m. tomorrow, and we'll have another informative session. So